In this short video, we shall familiarize with the use of a multimeter. The multimeter has a selector switch, and there are 3 terminals, 2 of which are always used at any one time. The center terminal is called the COM and is always used. COM is short for common. And in most cases we shall use the right hand side terminal, which is the volt, ohm, milliamp terminal. With the selector switch we can choose many functions. We can see that here we have the AC voltage, and there are 2 options. We also use these 2 terminals. Then we have the DC ampere, and there are many options where we can choose. We also use these 2 terminals for most of them, but if we select the 10 ampere choice, we have to use the other terminal, which is on the left hand side. This left hand side terminal is used for this option only. If we continue going round, we see resistance, and we can choose between different options. We use these 2 terminals, and finally we can see DC voltage. We shall start by measuring AC voltage. For this experiment we require an AC transformer. The output is AC, and we intend to measure 12 volts AC. And this is connected directly to the multimeter using the center terminal and the right hand side terminal. We switch on the transformer and we rotate the selector switch to a suitable voltage. We have chosen the 200 volt AC. This means that it can measure up to a maximum of 200 volts AC in this setting. But our output is 12 volts, so this will read 12 volts on the display. We shall now measure DC current, and for this we require a circuit with a resistor Q to represent the load, and we shall connect the multimeter in series with the load using the terminals COM at the center and right hand side 1. This is the circuit to understand clearly. We shall rotate the selector switch and choose the 200 micro. When we switch on, we see an out of range signal, so this means we have to choose another option, another higher selection, and now we have a reading on the 200 milliamp option. Now we read the value and we will see that it reads 160.6 milliamps. We also use the COM and right hand side terminal. We now measure resistance. This is called a resistance box with knobs representing units, tens, hundreds, and thousands. We can select any value of resistance. We connect the multimeter and we use the COM and the right hand side terminal. We have 100, 0 tens and 0 units, so it's 100 ohms, but the instrument is reading 101.4 ohms. We change the value of the resistance and we have 130 ohms on the box, but we can read 136.1 ohms on the meter. We have selected the range on resistance. We increase more resistance and we see that we have an out of range signal, so we have to select another option. Now we have 1130 ohms and it reads 1138 ohms on the 2 kilo ohm range. So the 2 kilo ohm range means it reads a maximum of 2000 ohms. We connect an unknown resistance to the terminals of the ammeter on the 2 kilo ohm range, and we can read at 218 ohms on the meter. We change to another resistance, so we remove the previous resistance and we insert another one. And we can see that it has low precision in the reading, so we will rotate the switch to a lower range to read better. So we can have a better precision in the value. And we read that the value is 6.5 ohms. We now measure DC voltage. For this experiment we require a circuit with some resistance Q, and this time we connect the multimeter in parallel to the load. A circuit diagram helps us to understand better. We switch on the power supply. We use the terminal COM and the right hand side one. We rotate the switch to the DC voltage range, but we have an out of range signal, so we have to go to a higher range until a reading appears. So the range is on 2 volts and we can read a 1.604. Notice that the last digit is very unstable. We can see clearly that we have chosen the 2 volts maximum, but it reads 1.603 volts.